Welcome to our second lesson, section 1.2. We're going to continue to look at rates of change. We're going to look at the equations, graphs, and tables to help us find both average rate of change and instantaneous rate of change. First of all, I want to just talk about a little bit of terminology that the book uses. When they speak of a general equation, they're meaning the formula or model for an equation. A particular equation would be that model or formula with values put in place of the variables. So a general equation for a linear value would be y equals mx plus b, whereas the particular equation might be y equals 3x plus 1. So just so that you're familiar with the book's terminology. Also, as we go through our year, you should be familiar with these types of functions. Hopefully you all are familiar with linear functions, functions that create a line, y equals mx plus b. You should be familiar with quadratics, y equals ax squared plus bx plus c. These are general equations, and you could put in values to come up with particular equations as well. Polynomial functions are any functions that have a series of terms with powers, and they can be in a variety of formats. Power functions are also another word or another way of showing that we have a single value raised to a power rather than polynomial functions that may have a series. Exponentials are values that have, or functions that have a variable in the power position, and we should be familiar with these as being exponential growth and exponential decay functions. Rational functions are any values or functions that have a polynomial divided by a polynomial. The most common rational function is the hyperbola, y equals 1 over x. Absolute value functions, we should be familiar with those as having a V shape. And trigonometric or circular or sinusoidal functions are those functions that we're familiar with that have a series or a repeating function that can go on, and it has cycles or sinusoidal graphs. So all of those functions are functions that you have been working with since Algebra 1 and right up through pre-calculus, and should be familiar to you. So that's just a little bit of terminology. You'll find that on page 6 in your textbook. And we're going to use a variety of functions in this section to look at a variety of ways to find instantaneous rate of change versus average rate of change. And let's just recap. Average rate of change is simply another way to indicate that we are looking at a slope between 2 points, and we are getting the average change over this period of time, and that would be found by f of x minus f of c over x minus c. The instantaneous rate of change, instantaneous rate of change is the rate of change at a particular point in the graph. It is found by the derivative, which we found in pre-cal to be the limit as x approaches c of f of x minus f of c over x minus c. We will continue with that later. Basically, the average rate of change is the slope of a secant line where the instantaneous rate of change is the slope of a tangent line. If you would now spend several minutes looking over examples 1, 2, and 3, and 4 in your textbook. Example 1 looks at just examining whether the change is increasing, positive, or decreasing. Example 2 looks at finding rate of change from a tangent line. Example 3 looks at finding values close to each other as we move x and c together to find algebraic values of a instantaneous rate of change. And example 4 does something very similar by using a table of values. Please look at each example very slowly and carefully. Look at the solutions and work through them with the textbook. And when you have finished, come back to our video lesson. Now that you've examined looking at derivatives or instantaneous rates of change through a variety of methods, we're going to write down a few definitions. First being the derivative. The derivative of a function f of x at x equals c is the instantaneous rate of change of f of x with respect to x at x equals c. Remember, f of x with respect to x is simply saying that we have some function f of x in terms of x that we are looking at, and we want to find that as x equals c, or as those two values come close to each other. Numerically, we can take the limit of the average rate over the interval from c to x as x approaches c, or graphically we can find the slope of the tangent line to the graph at x equals c. Again, numerically was when we found values closer and closer to c, and graphically is looking at a physically drawn line called the tangent line. The limit, which brings us to our instantaneous rate of change, L, is the limit of the function of f of x as x approaches c if and only if. So if and only if L is the one number you can keep f of x arbitrarily close to just by keeping x close to c but not equal to c. Remember, L and f of x both represent y values. X and c represent x values. So what this is saying is that as we keep x close to c, or as we bring our x values closer and closer, we are approaching a value L on the y-axis that would be called the limit. So as x approaches c, as our two values get closer and closer, my y value approaches L and stays very, very close to my limit. Now that we've finished lesson 1.2, I'd ask that you stop the video and work the homework problems for section 1.2. Please do all the Q questions, Q1 through 10, and all of the odd problems. Thanks a lot.